Hello everyone, here Pranay Lanjar once again coming with the topic of reinforced soil, which is based on our subject foundation engineering from the unit number 6. Okay, now first of all, what do you mean by soil reinforcement? Soil reinforcement is nothing but the technique which is used to improve the soil by improving its property as a stiffness and strength of soil by using of geoengineering methods. There are some methods used to improve, that is called the geoengineering methods. Okay, now use of natural fibers as a reinforcement is a old technique, but it did not have high yield and requirement and lot of time for the soil to recover. That's why the old techniques is not going to use in today's conditions. Okay, and soil reinforcement is necessary in land where the chances of erosion are high, soft soil area, high compressibility, poor shear strength, temperature changes, etc. Obviously, the soil reinforcement are necessary in these conditions. Okay, temperature changes where the high temperature and abruptly change in the temperature will get soil shrink, so there will be the chances of cracking, shrinkage, cracks, losing of shear strength. Okay, so that's why the soil reinforcement should have to be used there. In soil reinforcement, different engineering techniques are used to enhance the soil strength. Okay, that is called the soil reinforcement. So different techniques, that is nothing but, as we have already discussed, that is geoengineering methods. Okay, now what is the exactly mechanism behind the soil reinforcement? Actually, soil reinforcement is the improving its shear strength or shear stress by the friction. Okay, the flexible reinforcement interacts frictionally with the soil resisting the shear stresses in the soil mass. Okay, the shear stresses at the interface of soil and the reinforcement, there is obviously shear stress between the reinforcement and soil. Okay, which will generate the strain in the reinforcement, and tensile force is mobilized in the reinforcement. Okay, because in the friction there will be the stresses which are tensile stresses at the surface. So to mobilize or to restrict that soil reinforcement should be there. Okay, if this tensile force exceeds the tensile capacity of the reinforcement, rupture failure occurs, that is called the tensile failure. Obviously, that whatever the material we are going to be used, if the force or stress is going out of the capacity, then it may be failure, that is called the tensile failure or rupture. Okay, if the deformation are high or if interface is smooth, it is likely to slip occurs between the soil and reinforcement, that is pull out failure. If soil and reinforcement if does not rupture but soil gets slips over it, so that is called as pull out failure. For stability, tensile failure and pull out failure to be examined. Okay, because that reinforcement whatever we are going to provide to the soil reinforcement, these all should have to be satisfied or examined before the use. Okay, then only we can do the qualitative soil reinforcement. Okay, now that is the load mechanism. Again we are discussing that reinforced soil. That reinforced soil is nothing but has been introduced by Henry Vidal. He is a highway engineer and architect. Actually, he was trying to build a sand castle on a beach while playing over there. But the sand kept falling continuously. And what he do? He does uh, he do the reinforcing by pin needles. Okay, he does the reinforcing in that construction or that sandcastle by pin needle. That is how that concept has been introduced, coming into picture. Okay, the reinforced soil or earth is a combination of earth and linear reinforcing strips that are capable to bearing the large tensile stresses. The reinforcement provided by these strips enable to mass to resist the tension in way which the earth alone could not. Only earth, if there is not capable to take all the stresses, then the reinforcement should have to be done there. The source of this resistance to tension is internal friction of soil, because the stresses that are created within the mass are transferred from the soil to the reinforcement strip by friction. Okay, as this is the reinforcement and soil are composite section, so soil will transfer its load to the reinforcement whatever we are going to use, and the friction between them, that is the that will resist the failure. Okay, and these reinforcements are in terms of strip. Okay, so the what kind of materials we can use for the reinforcement. Okay, so as we know, the steel, concrete, glass fiber, wood, rubber, aluminium and newly introduced geosynthetics are to be used. Now, reinforced earth wall. Now exactly what it means. Now see the picture. In that picture there is a facing panel, okay, which is a concrete type. There are lots of panel are there which are restricting the earth, that is backfill. Yellowish type is your backfill. Okay, and beyond that again there is a general backfill or any type of backfill. Okay, but only panels are not capable to restrict that. So that's why the soil reinforcement, that is the white strips are there, that is the soil reinforcement, metallic strips has been introduced. Okay, and that backfill has been compacted, selected backfill has been compacted. Why? Because over it there is a road passing through over it. Okay, and there is reinforced earth block and base is there. Okay, so all the this picture will give you the whole idea of that reinforced earth wall. Okay, now what are the components we have to be see there is first picture, that is a panel of wall. Okay, at that panel there are four what we can say connection. Okay, four connections are there where we can attach the strips. In the fourth figure at the extreme right corner at the bottom there are strip has been shown. There are that is holding unit is to be shown. This holding unit, how this strip can be hold, there is a second figure. Okay, nuts are there. Okay, hole is there. Okay, reinforced strip connection at back face of panel. So whatever the blurrish type of is there, that will be in concrete panel. Okay, and this is the whole concrete panel at the right upper side. Okay, and there is a strips, you can see the strips. Okay, so that is the components of your wall. Geosynthetic polymer textiles can be used as a reinforcement and sandwich between the compacted layers of 0.2 meter to 0.4 meter. Okay, whatever we have been seen these strips, that can be a geosynthetic, and this has to be used as a sandwich between the soil, compacted soil. Geosynthetics in soil increase flexural, tensile and shear strength of composite. Okay, so obviously it is improvising that soil properties. Okay, geosynthetic reinforcement soil, that is ultimately called as a GRS technique, used in abutment, retaining wall, arches, steepened slopes, rock fall barrier, etc. Okay, so these are used in terms of these structures: abutment, retaining wall, arches, steepened slopes, and rock falls. Okay, now what factors can be affect to this reinforced soil? Okay, so there are the factors which are depending upon the whatever the material we have been used in that. So obviously we have been used two materials, soil and reinforcement. So it will be definitely depends on the property of that. So from the soil properties, what are the properties it will affect? Angle of internal friction of that soil. Okay, gradation of soil mass. Gradation is nothing but what? Gradation, that means what is the soil particle size, different soil particle size, that will affect. Okay, void ratio of the soil, that means what kind of quantity of voids or air present in the soil. Density of soil, how much denser it is, that is the factor affecting. Now from the reinforcement point of view, what is the tensile strength of reinforcement, that will definitely affect. Surface roughness of the reinforcement, obviously if it is reinforcement is more rough, then the friction will be more and the resistance will be more. Okay, and the surface is more slippery, the resistance will be more, smaller. Okay, so that is the surface roughness will introduce will take a part into the soil reinforcement. Length of reinforcement, obviously if we increase the length of reinforcement or strip, so obviously surface area going to increase, and surface area going to increase, the roughness is going to increase, and that roughness will increase the friction, and friction will again strengthen your soil. So that is the exact length of reinforcement will affect the that soil reinforcement. Okay, distribution of reinforcement, what type of distribution? Obviously we have seen in the concrete distribution what type of distribution we can do with the main reinforcement. If we are requiring 4 reinforcement and we are providing 3 reinforcement, obviously it will go into the failure. So similarly, how we are distributing with respect to the spacing, if a requirement with respect to the spacing we considered and we are not providing the with that spacing, so definitely we will lose that soil reinforcement. Okay, so it is more important, distribution of reinforcement should be qualitative at there. Advantages of the reinforced soil. So smaller quantities of earth fill are needed. Steeper embankments slope reduce the tech, uh, land tech required. Construction can be directly done on the soft ground. Okay, the technique is not separate operation in the construction process, but is a part of placing and compaction of the earth fill. Okay, that's why the structure can often be built more quickly than by the any conventional method. Okay, the reinforcement are lighter in the weight, so it can be casted or attached very easily. Skilled and experienced craftsmen not necessary, anybody can do the work if we are going to instruct or engineer going to instruct, so there is no need of skilled person. Low cost in construction over the other methods. It is feasible in more than 25-meter height. If the height is increased, that method is feasible. Now there are some limitations or disadvantages, we can say. Required large space behind or outward of wall. Okay, so there is a large space we will be in requirement while construction of this reinforced soil. Okay, unavailability of granular soil increase the cost. Obviously at every site there will be lack of your what granular soil in the sense gravelly, that means like as a sand is not possible to be obtained at every site. Okay, so that could be the disadvantages, and it will increase the cost if we are going to take it. Okay, designing and construction practices are in evolution stage, so no standardized practice available. This is the new method where right now it is already in the evolving condition. How to design, how to construct, what is the exact procedure we will have to follow, what is the exact practice we will have to follow. So it is not standardized yet, so that's why that could be the one of the disadvantages. Rapid corrosion of steel reinforcement is possible if you are going to use a steel reinforcement. So there will be the corrosion definitely, because the soil will be have moisture content, so it will corrode it. Polymer material degrade when exposed to the ultraviolet rays. Polymeric material, that means geosynthetic textile polymer, that is exposed, if they are exposed to the ultraviolet rays, it will be damaged and reduce the whatever the strength it does have. Okay, now this is the first part of soil reinforced soil, we can say. Now again, soil nailing is one of the type of soil reinforcement. So what exactly soil nailing means? Soil nailing is nothing but it is again a technique which used to reinforce and strengthening the existing ground by installing grouted steel bar. Okay, there is a grouted steel bar. Soil nailing consists of installing closely spaced bar into the slope or excavation as a construction proceeds from top to down. Okay, grouted nail increase the shear strength of soil. It is effective and economical method of constructing a retaining wall for excavation support. If you are doing a retaining wall construction, there will be the excavation, and do not fall that excavation to the construction site, so soil nailing should be at there. Okay, support of hill cuts also, to support that hill cuts we will have to provide the soil nailing. This process is effective in cohesive soil, broken rocks, shale or fixed phase condition. Okay, now what exactly soil nailing? That is, I have shown the figure. There is in the right side there is a soil backfill. Okay, earthen cut. So inside that what we have been provided one steel rod which are enveloped by grouting. Okay, first of all we will have to drill it, then we will have to provide a grouting, then steel bars. Okay, epoxy coated, there is a PVC centralizer, geocomposite drainage strip, temporary shotcrete wall, reinforcing steel. Okay, the all the components have been shown for of the nailing. Okay, now again at the joint, how it is looks, you can say reinforcement, shutted head, you can see the bolt nail head, washers. Okay, geocomposite strips, drain, steel bars, grout, welded mesh. Okay, so temporary facing, permanent facing, you can see over there. Now how it should have to be construct soil nailing, how it should have to be construct. First of all, we will have to excavate for the first nail. Okay, soil must be sufficient to self standing. Next step will be the install the first nail. Then construct first phase shotcrete on the soil face. Shotcrete is nothing but the forcefully concreting. Okay, by means of nozzle. Okay, okay. I will show it later on. The figures have been already added at there. Okay. Third step will be the install soil nail head plate. Okay. Now construct second phase, third phase. Okay, I will give you the another picture. Here it is. You can see the step 1, excavate the small cuts 1.2 meter from the platform. Okay. Now next is drill the nail hole by means of machine. Then third step, install and ground nail. Install and grout nail. Okay, that will be the third step. Now there is a what he is doing. He is doing shotcreting. Okay, place temporary phase reinforcement base, that will be seen after that. After that, fifth step is construction of subsequent levels. Level by level we can construct it. Okay, and final step, place final facing over that nailing. Okay, here it is, soil nailing wire mesh. This is the wire mesh, that is the nailing, you can see over there. Okay, these are inclined to the vertical faces. Okay, here it is, that is called a shotcrete. By the forcefully from the nozzle we are placing the concrete, and whatever the rounded portion is there, that is the what, nailing. Okay, you can see the bolt over there in the second just below of the hand of that worker. Nut is there, that is the nailing. Okay, that is the finished portion. You can see the nailing does have square portion, that is the permanent, and whatever the not permanent, that is the unfinished phase, that is the temporary. Okay, now application of soil nailing. So stabilization of existing retaining wall is the application. Excavating a retaining structure in urban areas for high-rise building and underground. High-rise building, there will be the excavation is much deeper. So for that, the soil nailing is introduced at there to restrict the soil fall down. Landslide redemption. Hilly portion there are lots of landslides, so we can avoid it by soil nailing. Stabilization of highway and roadway embankments, cut slopes, tunnel portal and unstable steep stratified slopes. Construction of retrofitting bridge abatement, steep cutting stabilization, stabilizing of over steep existing embankments, provide long-term stability of existing concrete structure without demolition of rebuilding cost. Okay, lastly, temporary excavation of shoring. Okay, so here I have been completed this soil reinforcement portion. I hope you have been enjoyed this PPT over the portion of reinforced soil and soil nailing. So thank you. Go through it. Thank you very much.